Hi there, students. In this video, we're going to learn another method to factor trinomials, different from guess and check, a little bit more procedural, and that's called the AC method. If you're the type of student who likes step-by-step instructions, this may be the method for you. This will work on any trinomial, so let's see how that works. Say you have the following polynomial, which may look familiar, but I just want to hit home that guess and check and the AC method will work for any polynomial. You can pick what you like. AC method can really be broken up into two steps. Okay, we're going to try and write this trinomial as a 4-term polynomial instead of 3 terms. We're going to do that by splitting the middle, which I know you don't know what that means yet, but we'll go through it. Once you split the middle, the reason we do that is so you can factor by grouping, which again we'll go through. Of course, math teacher says there's only 2 steps, but you see A, B, and C for each step. There's multiple parts. But I promise it's not as complicated as it looks. Let's go ahead and get started with this process. So our first step is to rewrite the trinomial here as a 4-term polynomial. We're going to do that by splitting the middle. So what split the middle means is you're going to split the middle term into a sum or difference of 2 other terms. So I could split this into, for example, negative 10x plus negative 10x. That would be the equivalent to negative 20x. We can't just pick any term we decide, though. We have to be strategic so it winds up working when we factor it. And that's where these steps come in. In order to pick the terms to split the middle, we're going to look at the product of the coefficients a and c. And the reason we're calling these a and c is because any trinomial is usually written in the form ax squared plus bx plus c. So 3 is a, negative 20 is b, 12 is c. So we're going to look at the product of a times c. So I'm just going to make a little chart here. We want a times c, which in this case is 36. So we want our terms to multiply to be 36, and we want the factors we choose to also add to be the middle term, which is negative 20. So let's just start listing out factors of 36, similarly to what I would do for a guess and check. So since it multiplies to be positive but adds to be negative, both terms will need to be negative. So we could have negative 6 and negative 6, negative 12 and negative 3. Neither of these add to 20, though. I'm going to keep going until I think of something that works. Oh, that doesn't work either. So I guess our last option would be negative 2 and negative 18, which will add to that negative 20 here. So we can use these factors to just rewrite this as an equivalent expression. Instead of using negative 20x, I'm going to write negative 2x and negative 18x, which would add to give me negative 20. So let's just rewrite that over here. 3x stays the same. I'm splitting negative 20 into an equivalent negative 2x plus a negative 18x, or just minus 18x, and 12 stays the same. So I want to emphasize that both of these expressions are the same. I'm just thinking strategically about how I can rewrite this to help me factor. Okay, so we multiplied a and c, we found the factors that add to the middle term, and we split the middle so we can create a 4-term polynomial. Done, done, done. The reason we did all this is so we can do what's called factor by grouping. The reason we can't factor by grouping from the start is because we have an odd number of terms. Now that we have an even amount of terms, we can group this polynomial into 2 different groups. So here's group 1, here's group 2. Now, it doesn't matter the order of the negative 2x and the negative 18x, it should work even if you switch them around. So factor by grouping, what you're basically going to do is factor each group. So I'm going to factor just this, and then I'm going to factor just this. So if you have 3x squared minus 2x, the only thing you can do is pull out a greatest common factor, or GCF. So what do 3 and 2 have in common? Well, I can only pull out a 1. X squared and x, I can pull out 1x. So if I pull out 1x, what's left over? X times 3x will give me 3x squared. X times what will give me negative 2x? The answer would have to be minus 2. Let's do the same thing for group 2, remembering that all these things are being added together. So I'm going to add this with this group over here. So out of 18 and 12, I can pull out a 6. 6 times what gives me negative 18x? It has to be negative 3x. 6 times what gives me 12? It has to be positive 2. Hopefully you're noticing that these groups are very similar. They just differ by sign. The beauty of factor by grouping is that whenever you do this process and split the middle, these 2 binomials should match, because it's going to help us rewrite this as a final product of binomials. So in order to make these match fully, all we have to do is change the sign. So instead of pulling out a positive 6, what happens if we pull out originally a negative 6? So negative 6 times what gives me 18x? That would be positive 3. Negative 6 times what gives me positive 12? It would have to be negative times a negative. And now these binomials match 100%, which you'll see why this is helpful in the next step. So we split the 4-term polynomial into 2 groups. We factored out the GCF, or just factored each group, and the binomials match. Check. So now what we want to do is rearrange the multiplication to get our 2 binomials. As I look at this expression, I notice that it's really repetitive. I wrote the 3x minus 2 different times. So instead of repeating that, let's just write it once as 3x minus 2. And instead of writing that it's being multiplied by x and it's being multiplied by negative 6, we can just tell another binomial what to multiply 3x minus 2 by. So one thing we have to multiply 3x minus 2 by is x. So this x would get distributed to both parts. We also have to multiply 3x minus 2 by negative 6. So as I write that in a binomial and you think about what this means, this expression here means I multiply 3x minus 2 by x and I multiply 3x minus 2 by negative 6 by definition of double distribute. So if you think of double distribution, these 2 problems or expressions are equivalent. So that's what it means by rearranging the multiplication to get our 2 binomials. And this would be our final factorization. If you want to double check, we can always guess and check. So 3x times x give me 3x squared. My outers give me negative 18x. My inners give me negative 2x, which you combine to get negative 20. And my last give me positive 12. So I know I've completed this. Again, this was factoring by the AC method. It's up to you whether you choose guess and check or AC. If you like steps, this is really nice. If you want to use a combination of this and guess and check, it's up to you. I hope you learned a lot, and please come with questions. Bye-bye.